So last week we stopped at derived the basic equations of electric and magnetic fields in an uniform plane wave which is propagating along plus x direction backward. And just to recapitulate, we find that dy xt was E0 cos of omega t minus beta z along J. I think it's going and h xt was E0 by beta naught cos of omega t minus beta z, where beta naught was square root of mu naught by epsilon naught. This is also called the intrinsic impedance. If we extend our discussion to perfect dielectrics and speed was phase velocity of vc equal to 1 by mu naught. That was speed of light. So this we had seen in the last class. So we continue from this point. Uniform plane waves in a perfect dielectric medium. So can anyone guess how will these equations be modified for a perfect dielectric? Everything is same. We assume that the field is the wave is propagating on plus x direction. Okay, and we have Ey and Hz. So what changes will take place if we consider perfect dielectric instead of vacuum?
So there will be relative permittivity or relative permeability term.
Relative permittivity will be there, that is right, but relative permeability term will not be there because mu r, just keep this in mind, mu r is not equal to 1 only for magnetic variables. Okay, like some iron alloys, iron those things. For any other, anything, everything else, mu r is 1. So for any perfect dielectric, for any dielectric, you can take mu r equal to 1. Okay. So for a perfect dielectric, what he rightly said, for perfect dielectrics, epsilon r is not equal to 1. So how will our equations be changed? E will remain the same. E equal to function of xt not cos of omega t minus beta z. This was j, right? The first change will come here. H xt will be E naught by eta 1, not eta naught. Cos omega t minus beta z t eta naught equal to mu naught epsilon r or beta naught by square root of epsilon r, right? And wave velocity will be v will be 1 by mu naught epsilon r, that is c by square root of epsilon r. Is it okay? So for dielectric materials, the speed of electromagnetic wave is lower than compared to that by a factor of 1 by square root of. Any doubts?
sir.
This should be beta dashed. Okay. Now next is not perfect conductor. EM waves in imperfect conductors. Okay. Now what is meant by imperfect conductors? Imperfect conductors means that sigma is not zero. Sigma is less, but it's not zero. So some amount of conduction current will be present. So how will the Maxwell's equation be modified? If we assume phasors in terms of phasors, the Maxwell's equation can be modified as curl of E, that is minus G omega mu naught H, curl of H equal to sigma E plus G omega epsilon naught epsilon R. This equal to this equal to 0. Is it okay?
The sigma is less, but how much less?
Less means C. Uh, how much less means it can be not zero, but still it can be like this component is much lower than this component, but this component is not zero. Understand? This is
Okay,
equal
sir.
to JC plus JB, right? Conduction current and displacement current. So this is much less than this, but this cannot be used. For dielectric materials, for dielectric, this is zero. This is zero. Okay? And please keep in mind this will be beta neutral, right? For this one, it is not beta, this will be beta, right? Because this must hold. If V is less than C, then lambda should be less than lambda prime, and beta prime should be beta prime. So we take curl of the first equation, curl of E, that is equal to J omega mu naught curl of H, and we once again replace curl of H in the second equation. Is it okay to write this?
Yes, sir.
Hmm? Right. Once again, this is equal to right. This was zero, so this goes. So we have once again this equation. We can write. We can write this. Okay.
Yes, sir.
Now, we take this entire term equal to gamma square. Gamma is propagation constant. So our equation becomes, can you remember where we have seen this type of equation? Things like this.
In transmission line.
Yes. in transmission lines, right? And how? What was the solution for transmission line equations? If the equations are same, the solution will be the same as well. So we take one page from transmission line and we can have three solutions. E equal to E1 e to the power of minus gamma x, E equal to E2 e to the power of gamma x, E equal to E3 e to the power of minus gamma x plus E4 e to the power of gamma x. So what does this mean? What does number 1 mean? What does number 1 mean? We have discussed. Number 1, what is the significance of number 1? It is a wave propagating in which direction?
Sir, plus x.
Plus x. And number 2?
Minus x.
Minus x. And
Six.
third one is 1 plus x, 1 minus x.
Standing.
Standing wave pattern. Very good. Very good. So we are interested about this one only. Okay. But know that 2 and 3 can also be solutions. No problem. So equal to E1 to the power minus gamma x. And once again, as per assumption, what we did, this discussion about the last class discussion, that it will have only y component. Although it is not necessary, you can have both y and z components. We will see that in implementation. For a convenience, we will G. Real part of this to the power of G omega. Right? We will put the e to the J omega t term as well. This will be the solution. The only problem here is now this gamma. What is gamma? Gamma square we have taken it to be what? This term, where was it? J omega mu naught times sigma plus j omega epsilon naught epsilon r. This we have taken to be gamma square. Okay. Let us simplify a bit. That is equal to j omega naught mu sigma minus omega square mu naught epsilon naught epsilon r. We can write this. Okay, agreed?
Yes, sir.
Okay.
Yes, sir.
We also assume that gamma equal to alpha plus j, because gamma square is a complex number, so gamma is very likely to be another complex number. It will be a complex number, right? Because square of a real number is there. It cannot be complex. Okay? So we need to find alpha and beta. How to find it out? What is gamma square? Gamma square will be alpha square minus beta square plus 2j alpha beta. Okay? Agreed?
Yes, sir.
So
Yes, sir.
comparing the real and imaginary parts, alpha square minus beta square, this will be minus omega square mu naught epsilon r, and 2 alpha beta will be j mu naught. Omega mu naught sigma. Correct?
Yes, sir.
Okay, fine. Now we use the formula from our childhood days, that alpha square plus beta square whole square equal to alpha square minus beta square whole square plus 4 alpha square beta square. Okay. So this will be omega to the power of 4 omega square epsilon naught square epsilon r square plus omega square omega sigma square sigma square. We can write this. So this is equal to omega square mu naught square sigma square plus omega square epsilon naught square epsilon naught square. That is alpha square plus beta square whole square. So alpha square plus beta square will be omega mu naught sigma square omega square epsilon naught square epsilon naught square to the power of half, and alpha square minus beta square was what?
Sir, it will be sigma square omega square.
Sorry? Where? I can make mistake. Where? Which one?
Sir, in the first line of
Here. Here. I am taking the square of this, so this will be omega to the power 4 mu naught square.
okay, sir. Okay, sir.
Okay.
Sorry,
No,
my
it's okay.
mistake.
It's okay. I can do it. No problem. No issue at all. Omega square mu naught epsilon. So what is 2 alpha square? 2 alpha, sum of these two, or here 2 plus square or not? Let us check. We can actually take okay, no problem. This can be taken as omega mu naught. This term can be further simplified as we can get this out. Can we write this? This term can be written as this term or not? What do you think? Is it okay to write this? This one, alpha square plus beta square. We can take the entire thing out except sigma square. Is it okay to write this? If we do, then we can simply add these things. So this will be omega square mu naught epsilon naught 1 plus sigma square omega square epsilon naught square to the power of half minus 1. Is it okay? Or what will be alpha then? Alpha will be simply omega naught square mu naught epsilon naught by 2 1 plus sigma square is it coming? If you do the same thing, you will get that beta equal to everything same only here is plus. Let me check my notes if I write this correctly or not. Just 1 second. Yes, it is correct. Is it okay? That is how we can find alpha and beta. Now tell me one thing. Tell me one thing. If sigma equal to 0, then what is alpha and what is beta? If sigma equal to 0, then what is alpha and what is beta? Just put sigma equal to 0 in the expressions and tell me what is alpha and beta.
Alpha 0.
Alpha is 0, very good. And beta? epsilon naught will be there. What will be that?
Omega square mu 0 eta r.
Beta will be omega mu 0 epsilon r epsilon naught, right? This one, and if you see that this will become 2 pi by lambda prime, where lambda prime is lambda by epsilon. Just check. This is equal to what? Omega is 2 pi f, and this is c by epsilon r. Sorry, the lambda, right? This is equal to this 2 pi gets cancelled. Sorry. This is equal to what? Lambda. So 2 pi lambda. So pi lambda. This will be beta was omega. Beta was omega epsilon naught. This one. Okay. So this is equal to 2 pi f mu naught, right? But 1 by mu naught epsilon naught is c. So this becomes 2 pi f c epsilon naught. This is beta epsilon naught. So if it is a perfect dielectric, in other words, if sigma is 0, then we see that alpha is 0 and beta is, we come back to the expression for the perfect dielectric. Now, so what do we have here? E equal to EZT equal to, sorry, Ex, real part of E naught e to the power of minus gamma x e to the power of j omega t j. Is it okay? This is what we found out, right? That is equal to real part of E naught e to the power of minus alpha plus j beta x e to the power of j omega t j. You can write. See here, E naught is real and e to the power of minus alpha x is also real. So we can take it out. E naught e to the power of minus alpha x, real part of e to the power of j omega t minus beta x. You can write this, right? So our expression becomes E naught e to the power of minus alpha x cos of omega t minus beta x j. So what is the interpretation of this expression? How can we interpret this expression? You see that it is very similar to the plane wave, but here there is an additional term. How will the additional term contribute? Why beta become pure complex? Because here alpha is pi naught. See, beta is not complex. Beta is real. What is complex is this term. Don't get confused. Okay. If alpha is 0, then gamma is equal to j beta. Gamma is complex, but beta is real. You understand the difference? Don't get confused with gamma and beta. If alpha is 0, we can write gamma equal to j beta. Beta is a real number, but gamma is a complex number. And if alpha is 0, then gamma is a purely variable number. Okay. So how does alpha contribute in the wave? What is the contribution of alpha? This additional term. This is coming. if I tell you to plot, probably you have done these things in control system or even circuit theory. If I tell you to plot that xt equal to e to the power of minus alpha t sine 2 by ft, how will the curve look like? How will it look like in the curve? If I plot xt and alpha is greater than 0. Okay? So how will the curve graph look like? Oh, last beta value, sure. Which one? This one? Here.
Yes, sir.
So the idea is to tell you that for a dielectric medium, be it perfect or imperfect, the beta changes from the beta in vector. Okay, that the beta is not the same. And how does it change? That beta is equal to beta not into beta in vector times square root. Okay, thank you. So, can anyone plot this graph xt equal to e to the power of alpha t sine 2 by ft, and alpha is positive, not greater than 0, positive. How does it look? It looks something like this. This exponential decay. The drawing is very bad. Sorry. But does it look like this exponential decay wave? Do you agree? Something like this. The waveform looks something like this. Right? Something like this is the exponential decay with t. Now tell me, how will this curve look like? How will this look like? How will this look like? And a request, please note down the values of alpha and beta in your copies, because we will be using them later in this class. So please note this down, these values, because we will be referring to them. Okay? Just take a note. Beta in this class will be. In the books, you will get these expressions, but you will not get the derivation. Any book, we will give you these final values, but we will not give you. Okay, you can note. Okay. So how will this wave look like? This expression of ext. How will this wave look like? This will be attenuated as it propagates along its direction, right? So this alpha is called the attenuation constant, similar to the transmission lines. Its units is vapors per meter, and beta is called the phase constant. Its units are radians per. Okay. So any questions regarding this? And And what will be the magnetic field? What will be the magnetic field if E is equal to E naught to the power minus alpha x cos of omega t minus beta x g? We find out using the same thing, curl of E equal to minus g omega mu naught h. So we find curl by this one I g t del del x del del y, this is 0, del del z, this is 0, this is E naught to the power minus alpha x cos of omega t minus beta x, this is 0. So once again only k term will be remaining, and so this will be minus j omega mu naught h, that will be del del x of E naught to the power minus alpha x cos of omega t minus beta x. So if we differentiate this one, so two terms E naught minus alpha E naught alpha x cos of omega t minus beta x plus minus beta E naught to the power minus x cos of omega t minus beta x. Right? That is equal to j mu naught h. That is equal to minus j mu naught h. Right? Something actually one mistake. Since we are considering phasor, this should also be phasor. You understand? Because we were considering phasor quantity, so we cannot take this one as vector. That will be wrong. So j omega naught mu h, that is equal to if we differentiate this alpha plus j beta mu naught to the power alpha plus j beta x. Okay. So h equal to alpha plus j beta omega mu naught to the power alpha plus j beta. Now take, so h equal to mu naught by beta to the power alpha plus j beta x, where beta is equal to omega mu naught alpha plus j. This is the and as expected, this time it will be complex because both real and real terms. Now you can put the values of alpha and beta, whatever we got there, and you can find it out. Okay. So any questions? Next session we will discuss first loss tangent, and then we will move on to wave propagation for your good conductors. Okay. Let me give you attendance.